Okay, so in today's video, we're gonna learn how the calculations work in trigonometry. And the reason I'm making this video is because I've noticed a lot of people struggling with understanding how the calculations work, and most of them just tend to apply the methods their teachers have taught them instead of understanding why the methods work the way they do. And I would highly recommend people learn this so that it becomes easier for them to understand, and in turn it makes the questions, even if they're difficult, seem easier. Okay, so we're gonna start off with the same unit circle we started off with at the start of this series, and we know that this hypotenuse on a triangle will be 1, and that this length and this length is sine theta and cosine theta, which we found out at the start of the whole trigonometric series. So I'm gonna just write that down for you so that it's a bit easier to remember and understand. So this is sine theta and this is cosine theta. Now pay attention to the theta because that concept's gonna get a bit more confusing. So basically, last time we supposed that this angle that we marked here was theta, but from today onwards, I'm going to call this the basic angle, which we denote by alpha. So this is alpha, and the reason I'm calling this the basic angle will become pretty self-explanatory soon. But what I'm going to do is I'm going to draw a an arrow basically to the hypotenuse that's going counterclockwise from this point in the first quadrant. So this I'm going to call theta. So for now, I'm going to say that the basic angle and theta are the same in this quadrant, the first quadrant. So this is the basic angle, this is theta, till the hypotenuse, right? So now notice that if this length is sine theta and this length is cosine theta, both of these are on the positive axes. This is on the positive y-axis and this is on the positive x-axis. So if this is on the positive y-axis and this is on the positive x-axis, I can say that both of these are positive. And since we know that tan theta is sine over cosine, then if I do tan, I don't need to write sine each time. I can just write the symbols for explanation. We know that sine is positive, and we know that cosine is positive. So if I do plus over plus, then that is gonna give me a positive answer. So that means in this quadrant, sine, cosine, and tan is positive. So that's why this is denoted by A, which means all trigonometric functions are positive. And with this logic, we're going to move to the second quadrant. And in the second quadrant, you're going to notice something funny, which is that you still have the same line, which is the hypotenuse, which is equal to 1. And you're going to have the same triangle, but practically mirrored on this side. This is 90 degrees. I'm not going to label the adjacent and the opposite each time, but we know that this is sine theta and this is cosine theta, right? So what this is, notice here I marked this as the basic angle. So the basic angle of this triangle and this triangle are going to be the same because this is also 1, this is also sine theta, and this is also cosine theta. So I'm going to mark this as the basic angle. So for now, this triangle seems the exact same as this triangle, right? But the difference now is that theta is not the basic angle. Theta is basically the counterclockwise movement from this point, this axis, the positive x-axis, the first quadrant, to the hypotenuse of our triangle. So in this case, if I have a triangle here, then theta defines this whole angle. So if I have a triangle in the second quadrant, the basic angle will be the same for all triangles, right? But theta in this case, it's going to the hypotenuse. So theta in this case will be greater than 90 degrees, which might confuse you in the start. But you need to remember trigonometry is all but ratios. It's a play on ratios. So it doesn't matter if theta is greater than 90 degrees because in the end it basically means the same thing. So because the basic angle is the same, notice that it's still the same triangle. So that's why theta can be greater than 90 degrees. So in this case, this was alpha, this is theta, and now this is theta. So this will always be greater than 90 degrees. And if I want to find theta, what I can do is I can do 180 minus alpha. And the reason for this is because this whole length is 180 degrees, right? So if I subtract alpha from this, then I'm going to get this angle that I marked theta. So this will 180 minus alpha is how I get the angle for the second quadrant. And now notice here that sine is on the positive y-axis up here, but cosine is pointing on the negative x-axis. So now I can see that on here, sine is positive and cosine is negative. And if sine is positive and cosine is negative and tan is sine over cosine, then if I do a positive integer divided by a negative integer, I get a negative value, which is why we say that in the second quadrant, sine is the only thing that's positive. So that is where the S for the second quadrant comes from. And by applying the same logic, we can also derive for the third and fourth quadrants. So let me just show you that practically. Notice here that I'm going to draw the exact same triangle that we drew in the other quadrants. It's going to have the same hypotenuse and the same basic angle. This is 90 degrees, and this is the basic angle right here. This is the basic angle. So this is the basic angle, and for now, notice this is the hypotenuse. This was one, right? So as I mentioned earlier, theta is the angle till the hypotenuse. So in this case, the angle theta will travel like this. It's basically gonna travel to the inside of this triangle, and it's gonna make the angle here, like so. So now this is theta for the third quadrant, and this angle is 90 degrees, as I mentioned earlier. This will still be sine because note basic angle is same, the hypotenuse is same, and this is cosine, right? So now notice here that sine is pointing in the negative y direction, and cosine is still pointing in the negative x direction. So if sine is negative, if cosine is negative, then tan is negative over negative, which we know is positive, right? Because the negative symbols cancel out. So that means that in this quadrant, tan is positive, which is why we say the third quadrant is T, which means tan is positive. And to find theta in this quadrant, notice how I mentioned earlier that this whole rotation is 90 degrees, right? 180 degrees. This whole rotation is 180 degrees. So if I want to find the whole of theta here, like this, then instead of doing anything else, I can just take this 180 and I can add this basic angle right here onto it. And then I'll get the angle theta, which starts from here and goes all the way around. So I can say to find theta in the third quadrant, I can do 180 plus alpha. Alpha in this case is the basic angle, obviously. So this is for the third quadrant. And for the fourth quadrant, we do the exact same thing. We start off with the hypotenuse. We draw the opposite. We mark the angles. This is the basic angle. This is 90 degrees. And this is sine. This is cosine. This is 1. So now notice that sine is pointing in the negative y direction, cosine is pointing in the positive x direction, and tan, as a result of that, since this is negative and this is positive, then I can say that sine is negative, cosine is positive, then tan is negative over positive, which is equal to negative. So that is why this quadrant is called C, which means that cosine is positive in this quadrant. And again, the counterclockwise movement we talked about earlier still applies here. So I start from here and I move counterclockwise. I made a very wonky spiral, but I hope you get the idea. This is the direction you move in. The blue line spiral is basically theta for this quadrant. So this is theta for the fourth quadrant, and oh, my bad. Theta will actually be till the hypotenuse. I forgot. So this is the hypotenuse, right? So we move from this all the way to the hypotenuse, and this is theta. My bad for that. So this is theta, and notice that a circle has 360 degrees on its center. So what I can write this as is I can say that to find this whole angle theta, I can subtract alpha from 360. So I can say that this is 360 minus alpha, which gives me the whole angle theta. So this is where the derivation basically for ASTC comes from, that all trigonometric functions are positive in the first quadrant. This is the first quadrant. Uh, Only sine is positive in the second quadrant. Only tan is positive in the third quadrant, and only cosine is positive in the fourth quadrant. This is where all of this comes from. And again, if you want to write this for radians, it's all the same thing. Here, the angle theta is equal to alpha. That doesn't change. Here you can say that theta is equal to pi minus alpha instead of saying that it's equal to 180 minus alpha. Here you can say that theta is equal to pi plus alpha. And here you can say that theta is equal to 2 pi minus alpha. So it's all the same thing. Radians is just basically swapping out the degrees for the radians. So it's not that much of a difference. And this is how the positive angles theta work. Okay, so some of you might be wondering about the negative ranges, and you're right to think about that. So we're going to use the same concept, and I'll speed it up a bit more since you now have an idea of how all of it works. It's gonna have all the same triangles. Let me just draw the hypotenuses. And then we can connect these with the x-axes. Like so. Just ignore the fact that it's not connecting properly. It still kind of makes sense. Anyway, so basically, now for negative thetas, what we do is, instead of moving counterclockwise, we move clockwise, because now that constitutes a negative direction. And for context, to make this easier to understand, we can label this 0 and negative 360, and this is negative 90, this is negative 180, and this is negative 270. I forgot to mention this in the previous circle, but it works the same way, but just counterclockwise. So this will be 0, this will be 90. This in the positive circle, this will be 90, this will be 180, this will be 270, and this will be 360. It's just the same thing, but now we move counterclockwise. And the same thing still apply. ASTC still stays the same. So this is ASTC. And now notice that what we're going to do is, if this is negative 360, this is negative 90, not negative 270, right? So if I want to find, let's say, we all know that these are all the basic angles, right? So if I want to find theta, we knew that it's from the starting point to the hypotenuse. So now we apply the same rules, but in the opposite direction. So how that works is, basically, if this is alpha, this is alpha, this is alpha, and this is alpha, then this angle is theta. So now notice that the fourth quadrant is alpha is equal to minus theta. It's not alpha is equal to theta, it's minus theta, negative theta, because when you rearrange that, you get that theta is equal to negative alpha. And that is because we're moving in a negative direction, right? So that's pretty self-explanatory. And then we just do the same thing here. We move in this direction. And notice how the same logic, this whole thing is 180 degrees. So we subtract alpha from this. So what we get is theta is equal to negative, because negative. And then in a bracket, we write 180 minus alpha. 180 minus alpha. So basically what we're doing is we're taking this as 180, we're subtracting alpha from it, and we're putting a negative symbol on it because it's negative. And you can do this so on and so forth. You move till here, then you get 180 plus alpha with a negative sign outside. You get negative 180 plus alpha. And on this quadrant, you get the same thing, but now notice that the first quadrant is the one we do 360 minus alpha in. So this will be theta. So we say that theta is equal to negative 360 minus alpha. You need to remember that the negative sign stays there. And what all of this is basically is you only apply this when the question has specified that theta lies in a range that is in a negative value as well. So it needs to be like something like negative 180, or for this case, I'll say negative 360. So now you can apply your teacher's methods and also know what's going on. The reason why negative moves in the opposite direction because it's negative. So anti-clockwise becomes clockwise. So you need to make sure that the range is also negative for you to apply this, and this gives you more solutions obviously because you're finding more answers. So I hope all of this helped you understand a bit more better how and why ASTC works, and how negative quadrants and positive quadrants work, and why we have more than one solution for just like one question.